Well, welcome to week number 9 of CS394R Applied Probability. And this week we're going to cover just one lecture, that is lecture 14 on the Bernoulli random process. And this lecture is going to kick off our next series of content on random processes. And we'll dig into all of those as we progress through this week's content and kind of do a quick high-level overview of what the different processes are that we're going to follow. But this week we're going to focus on the Bernoulli random process because it is the simplest of the 3 random processes that we'll be studying. Now, looking through the lecture material for lecture 14, we're going to first introduce the Bernoulli random process. We'll then take a step back and look at stochastic processes in general and just kind of define what a stochastic process is and why they're useful. After that, we'll return to our Bernoulli process and start looking at some basic properties, go over our expected values, our variance, same thing as we've been doing for all of our random variables to date. And then we'll take a little bit of a look at some specific applications of Bernoulli processes. For instance, identifying the time of the kth success or the kth arrival and inter-arrival times, that is the time from one success to the next. And then we'll look at the merging and splitting of independent Bernoulli random processes. If I have 2 different Bernoulli random processes that I want to merge or sum or basically say did one or the other happen, how do I do that? And then the same applies with splitting them. How do I split those back out? And then we'll take another look at Poisson distributions and specifically the Poisson approximation of the binomial random variable and how that applies to the Bernoulli random process. This week we'll have only a quiz just to give you a chance to focus on the exam that's coming up next week. And with that, let's go ahead and get started.